first and then get back to what's constant here. All right, so the question, I guess I started out with, what is this? Is it a constant direction?
Yeah.
We got a no over there and a yes over here. And fight. Remember, physics disputes are resolved with a knife fight.
I didn't bring it with me today.
Going in a different direction, the graph, the line of the graph would change also.
What do you mean change?
Like,
How?
so, I don't know what, okay, so this is going in the negative direction, so I don't know if that's right. But, and then it changed to start going in the positive direction, you have to show it on the graph of it going, right?
I caught some of that. So I'm going to speak loudly. Let's try it again.
Okay, so say this graph is going in the negative direction, I don't know if it is, but if it's going in the negative direction and it changes to start going in the positive direction, it'll show on the graph.
Okay. How does it show in the graph if you change from going from positive to negative or negative to positive directions? No.
Would it be all like,
No. See, what people are thinking here, and I noticed this on the, I guess it was the master set, people confusing velocity with position or displacement. Let's go back to something Louis said. What does the sign of velocity tell us?
direction?
Okay, okay, true. Something for something more physical.
Direction, positive or negative.
Okay. Apparently my reading skills are off. Again.
Okay.
What's wrong with you?
Direction of object?
Okay, it has devolved into a mind reading exercise. The direction of movement. That's what I was going for there.
That's what I meant, direction.
Yeah, I think several of you meant that, but
So, wait a second.
it's Monday, right? All right. On a graph, how do you, oh, Isabella?
I think I remember now. So it has to go past the, I'm gonna word it wrong, I already know,
That's fine.
but the time has to go past the line for it to change direction, right?
Yes.
Yeah.
You can't go from positive to negative without going through zero. This is zero. Above it, positive, below it, negative. Velocity is positive this entire time. You're traveling in the positive direction the entire time.
Nothing, I'm just trying to get this straight.
Okay.
Never mind.
I was not hearing anything you were saying, I just heard that you were saying something.
Okay.
All right, so my velocity is positive this entire time. If I change in direction, I have to cross this axis. So that's when you said it has to change, and I wasn't sure if you meant, that would have to change, it would have to become longer. Now it's changing direction.
Oh,
All right, so let's go back to what, so one observation is the fact that velocity is positive the entire time. What else is going on?
It's going towards the origin.
Say it again.
It's going towards the origin.
And what does that mean in terms of velocity?
Changing direction.
It's not crossing though.
It's slowing down.
Say it again. Somebody over there said it.
Slowing down.
Yes, that's what it's doing. My velocity is getting closer to zero, which means it's slowing down. So I start out at some speed. I'm going slower, but I'm not changing direction. I'm just slowing down as I go in the same direction. So if I looked at a position time graph, actually let's do displacement time. I start going fast. So if I had two speeds here on this, let's say I had two different objects moving. Which one's faster?
One with the greater slope.
Yes. This one's faster because in the same amount of time, so whatever time this is, whatever time that is, this one's traveled farther. So the steeper it is, the steeper this, my position time graph or my displacement time graph is, the faster it's moving. So it starts out steep and then becomes less steep because it's slowing down. Something like that. Now, the exact nature of the curve, I would have to give more information, but it's gonna look something like that. For those who have done some conic section stuff, if that's a straight line, this will be part of a parabola. If that doesn't mean anything to you, then don't worry about it. But- All right, questions to hear before I'm gonna ask a follow-up to this, but I wanna at least get us hopefully on the same footing as well. Any questions up to here? All right, so Latoya and Brianna?
So it's going down, you said that the velocity is constant.
It's getting slower. We still have to get back to what is constant over here. Velocity is not constant, because the constant velocity would look like that.
The acceleration.
Yes,
The acceleration is constant.
acceleration is constant here. Because,
I'm sorry, I literally have classes, so I'm
I'm not throwing stones in that glass house, so. but- Why is the acceleration constant? What-
The change in velocity?
There is no change.
No, there's no change. Okay.
There is a change in velocity.
Yeah. Oh, okay, that's right.
Because if the acceleration was going up and down, then it would look hard.
Okay. Sort of putting that together. There are a couple of bits and pieces, so hopefully I'll bring in the bits and pieces. A line, if it's sometimes just called a straight line, but if it's a line, the slope is constant. And the slope of my velocity time graph is acceleration. So acceleration is constant.
That's right.
If I take any 2 points on this line, and I look at how much velocity changes and how much time changes between those 2 points. The change in velocity over the change in time is acceleration, that's constant. Now, at least 2 of you said the change in velocity was constant. There's the time aspect there. For the same amount of time, the change in velocity is the same, but you do have to bring time in somehow. Because the change in velocity from this point to this point is not the same as from this point to this point. So just saying change in velocity is constant, you're leaving out an important aspect.
So velocity is constant, or acceleration is constant when your slope is constant.
Yes, when the slope of velocity time. You got it messed up there, fine. Positive acceleration or negative acceleration?
Negative.
Negative, because it's going down.
It's
It's
slowing
slowing
down.
But it's in the positive.
All right, let's jump on that last thing that I heard there. All right, I'm tired of these markers. I'm gonna just keep this running, and so all the international fans can just stare at the board for a little bit. I'll be right back with better markers.
Wait a second. It's positive. Okay, I know that. Every time it asks a question. Okay. I don't know why teachers us.
All right.
I know the answer.
What's that?
Oh, I said, I think I know the answer.
Yes.
Positive, because positive and negative doesn't mean speed, it means direction.
There is a direction aspect to it, but if I have a velocity versus time graph, if I want constant acceleration, this graph needs to be a straight line. So I'm going to do that right there. So 0 is here.
That was speeding up in reverse, isn't it? Sorry.
Say it again.
It's speeding up in reverse,
Why do you say it's speeding up?
because it's accelerating, it's towards the zero is slowing down, for spreading, going farther away from zero is speeding up for this one.
Yes. Well, the same thing true over here. I mean, going towards 0 is slowing down, going away from 0 is speeding up. You on a roll?
Yes, I worked so hard.
All right. Acceleration, positive or negative?
Negative constant.
Why is it negative?
Because velocity is also negative. And if, no, it would be positive because velocity is negative, it should be opposite.
If velocity and acceleration are opposites, speeding up or slowing down?
Slow it down.
But it's speeding up here. So here, my velocity is negative because I'm below the horizontal axis. So velocity is negative, and my acceleration is also negative. And you can look at it from the point of view, I'm speeding up, velocity is negative, acceleration has to be negative. Or over here, I'm slowing down, so my velocity is positive. My acceleration is negative. Or, from a math point of view, that's a negative slope. That's a positive slope. So negative slope, since this is velocity time, negative slope would mean that acceleration is negative. Questions up to here? Oh, that's right. I remember the question I was going to ask a while ago.
So you just look at the slope for acceleration?
That's what I do.
Okay. Just look at the easiest way. That's it.
As always, the easiest way is the way your mind is working at that moment. Or from the point of view of, I'm getting away from the axis, so I'm speeding up, velocity is negative, acceleration has to be negative also. Same sign, speeding up.
I was gonna ask this before we started going for it. So if the velocity was going in the negative direction, what would the what would the displacement graph look like?
So what's the displacement graph look like here?
Yeah.
All right, so I'm starting out at some speed in the negative direction. I go to a greater speed in the negative direction. So my displacement graph will be velocity is negative, so displacement has a negative slope. And it starts out at a low slope and goes to a steeper slope. So my displacement time graph let's see, displacement, so I'm starting at 0, and then it starts out at a low slope and then becomes more negative. So that's what the graph will look like. And I'm hoping, again, part of the dream, everyone else was looking at that and pictured that perfectly. This is the class that would do that. That'd be cool. Everyone with a perfect score on the test.
That's,
Tears of joy. If everyone gets a perfect score on it,
We just all get hundreds for the whole grade.
Yep.
The average grade will be 100.
I think I can safely say yes.
We end the semester right here.
On quizzes, I had a class of like 24. I actually, this number of years ago, actually had a question that everybody got full credit on. One question on a quiz, that was so exciting for me. Because usually there's somebody, even if it's a simple problem, everyone knows how to do it, there's gonna be somebody who miswrites, doesn't put the units down, or puts the wrong superscript or exponent. And we can blame Elaine, I guess.
In every class.
I had a bet with a class once that I would do the worm if they had done something absolutely amazing on a test. I felt safe. All right, here's the tough question. So your brains are firing right now. This is the displacement time graph for that velocity graph. What would the position time graph look like? Say it again? Like, do it over here, sorry.
It would be positive.
Meaning what?
I was just saying it's gonna be the positive.
Oh.
That's all I have so far.
So you're saying position time graph would be above the axis?
Yeah.
Is she right?
Oh, I think
I heard some nods and a very timid yes.
I think it would look like the velocity graph, wouldn't it?
No, it definitely would not. It's gonna look somewhat like this. The
Yeah.
position graph, because remember when, I've erased it now. Oh, here we have a position graph and a displacement graph.
What it look like the displacement will go like this?
Oh, curve. So this, except kind of looking more like the one over there?
Yeah, but above the,
So something like that?
yeah.
No.
It would start. It wouldn't start at the origin, would it?
Okay.
It would start at wherever. It would just not start there. It would start wherever, and then just go down towards zero. Closer to
You
zero.
started out almost there, and then you decided to go off on a tangent.
Just what I do.
It look like,
the top left, but just like, you know, above the axis and like pointing upward.
Pointing upward, as in curving like this?
I mean, like, just.
Oh, your hand gesture made it look like a straight line. It would not look like a straight line. The displacement time graph and the position time graph, those graphs look very similar. So the position of just part of it, position time graph is gonna curve exactly like that. All right, so Luis had his hand up, and then Brianna.
You can pick them.
Brianna?
Okay, is it gonna start like a little bit above where the displacement starts? And then like,
And then do that,
yeah.
and we've got some support from behind you. Luis, what are you gonna say?
I'm a little confused now.
Would it not start at the very bottom like the displacement does, because you're going from the point of origin on position graph? So maybe it would start a little bit higher and then slip over a little bit.
All right, so that's, I think, similar to what Brianna said before.
Oh, I didn't hear,
See, mind reading skills would really come in handy. All right. I'll put some of you out of your misery here. It's actually a trick question. All I know is that it's gonna curve like that. I have no idea where it's gonna start because I haven't defined anything. I don't know where zero is relative to the starting point. It might look like that, but that's supposed to look more like the one below it. Or it might look like that. Don't know. In this situation right here, you're starting on the negative side and then you cross over to the positive side. Because you're traveling in the positive direction, you just happen to cross over whatever the origin is. Or here, you start on the positive side and you just get farther away from the origin.
Right, because we don't know where the origin is if we're talking about
Right.
displacement. Okay.
And a couple of people got close to that. That's what, when you originally said it's about the origin, and then you decided to.
I didn't say parallel.
Sorry, you late?
We didn't say parallel.
And it should be parallel with that. That's really all we can know about the position time graph. If I gave you position time, displacement's easy, just shift it or up or down to starting at zero. But if I give you displacement, it's impossible really to know. I'm gonna let that sink in a moment. I'm going to now do an acceleration time graph and see what we can pull out of that. Here we go. Just, what's going on here?
I'll say acceleration.
All right. So that's time is 0, that's seconds, and make this 10 seconds, and make this 5 meters per second squared. So over the course of that 10 seconds, what do we know?
The acceleration stayed the same.
Okay, what else?
The velocity is gonna be, not sure why, but,
Oh, okay,
wait,
yes.
the one right there.
What would be the slope of my velocity graph? Yeah, 5 meters per second squared. So how would I draw it? Based on your hand gesture, it's gonna be something like this.
Yeah.
Where would I draw it?